Hi, I'd like to discuss the answer to the Time Value of Money quiz number 1 that you should already have. You can find a much better copy of this on the wiki, but I just wanted to discuss how to think about the answers on this. I have a reproduction of it here. It's a little bit abbreviated just because I'm trying to keep it on the board. But this was the series that started off with 1 in time period 1, it doubled in time period 2, it doubled again in time period 3, and it kept on doubling until it reaches $64 in time period 7, and after that it keeps cutting itself in half again. It's pretty clear what you're looking at here is from here to here, you're dealing with a geometric gradient that doubles every time period, and from here to here, you're dealing with a geometric gradient that cuts itself in half every time period. Now, I've split it up in one way, but there's an infinite number of ways of splitting these things up. I could have easily said that it is a geometric gradient that doubles from here to here, and it's a geometric gradient that halves itself from here to here. Both are fully appropriate, and you could even think about it as a geometric gradient that halves from time period 8 on, and a singleton sitting there at time period 7. So there's always an infinite number of ways of breaking these things up. But let's pick this division where I am with one part of the equation going to look at time periods 1 through 7. Another part of the equation we're going to look at time periods 8 through 12. This one over here is just going to be a geometric gradient that you do not have to time shift. This one's going to be a geometric gradient that you do have to time shift. So let's start with this one right here. First, with a geometric gradient, what you have to do is start off knowing what the time period 1 gain or loss is supposed to be. In this case, we know it's 1 right there. And what you're doing is you're looking for the present worth, given you know a sub 1. The interest rate is, for this example, arbitrary. You'll evaluate it later. And the tricky part is just trying to figure out what the n is. And this, for a geometric gradient, is just the number of non-zero values that you have. So we have 1, 2, 3, 4, 5, 6, 7 of these, and a 7 goes right there. So this takes all these values and dumps them over into time period 1. Simple. Now this part over here will take you into a different equation. This is also a geometric gradient. Oh, my mistake, I forgot a single element that we had right here. Growth rate is equal to 100%. There we go. Now this one right here is also a geometric gradient, but this one has a growth rate of negative 50%. It cuts itself in half every single time period. It's something that starts at 32 and then cuts in half, cuts in half, cuts in half, cuts in half. So let's start it off with 32. I'm looking for P, given that I know a sub 1. And please note that the thing that's on the other side of these parentheses right here is the thing that's immediately on the other side of the slash. So I know that a sub 1 is right there. I know that this number right here is a sub 1 because it's the thing on the right-hand side of the slash. The interest rate is arbitrary to us. Its growth rate is negative 50%. And n is the next thing you need to worry about. And this one is something that has 1, 2, 3, 4, 5 non-zero values. 5 goes right there. Now, please note when I give you these kinds of problems with these geometric growth rates, I'll commonly do something that's really easy, like 100% or 10% and minus 50%, because I don't want you to have to sort out what it is. I just want it to be something which was evident to the eye. Now, this equation right here would be great if we actually had a series that started at time period 1, but we've got a series that starts at time period 8. Clearly, this is something that needs to be time shifted. So what you can think of is that this numerator up here takes all this value in time periods 8 through 12, dumps it all onto time period 7, and then we have the added task of moving it from time period 7 back to time period 0. You do this with 1 plus the interest rate, and you're raising it to the power of 7. One of the ways that you can check that you've done it right is you can add the n and the exponent that's right there, add them together and get 12, and that'll give you the last time period when you have a non-zero value. And this should give you one of the answers to time value of money essential question number 1. Thank you.